In 1660, a curious English scientist named Robert Hooke was fascinated by how things stretch and bend. He wanted to understand how materials behave when forces act on them. One day, Hooke took a simple metal spring and started pulling it gently. He noticed something important. The harder he pulled, the more the spring stretched, but in a very predictable way. Hooke realized that the amount the spring stretched was directly proportional to the force he applied. This meant if he pulled twice as hard, the spring stretched twice as far. If he pulled 3 times as hard, it stretched 3 times as far. This relationship was very consistent and reliable. He wrote down this simple rule. The force needed to stretch or compress a spring is proportional to the distance it stretches or compresses. This became known as Hooke's law, often written as F equals kx. Here F stands for the force applied, x is the distance the spring stretches or compresses, and k is a constant unique to each spring called the spring constant. This constant tells us how stiff or soft the spring is. Hooke's discovery was revolutionary. It helped scientists and engineers understand elasticity, how objects return to their original shape after being stretched or compressed. This knowledge is crucial today. Thanks to Hooke, engineers can design bridges, buildings, car suspensions, and even measuring instruments that rely on springs, knowing exactly how much force materials can handle without permanent damage. Robert Hooke's law remains a fundamental principle in physics and engineering, helping us design safe and reliable structures and devices. So next time you stretch a spring, remember that you're experiencing the simple law Robert Hooke discovered over 350 years ago.